So 4.1, okay, we have a free body diagram. Now let's see how are we going to sketch free body diagram. So basic of forces and free body diagram. First of all, you need to recall types of the force that we have seen in our previous class. So in a previous class, what do we have? We have a normal force. Okay, we learned about normal force. So normal force is a force that is perpendicular to the surface area. And then we have a weight, which is depends on the object. Whenever you have object and then you have a weight, so remember the symbol, you cannot use a wrong symbol. And then what else do we have? Okay, we have normal force, and then we have weight, and then we have tensions. Tension is whenever there's a strings-like object, okay, that kind of pulls the object. So tensions is capital letter T, and now we have a frictional force, friction. So remember, frictions, we have two types of frictions, static friction or kinetic friction. Okay, and the last one is what we call external force. So basically, external force, we just use capital letter F. So these five are what we call basic forces in object. Okay, it can be X on the object. Okay, now let's see how to sketch a free body diagram. So I believe I showed you in our previous class as well. Okay, how to sketch free body diagram. So let's do a quick recall. So a free body diagram is defined as a diagram that shows all forces acting on a body, okay, regardless of whether it is the directions of motions or not. Okay, if it is the directions of motion, then we use that one. We use the second law for that one. If it is not, then we use first law for that one. All right. So regardless of the directions of motions, first of all, we need to plot all forces acting on the body. So we use a single point to represent the object. So remember, this is very important. Okay, you use a single point to present the object. Okay. It's wrong. Okay, so that represents the object. So first, identify how to draw a free body diagram. Identify all forces acting on the object, and then you draw a coordinate system, which is the x and y axis. Okay, so coordinate system basically refers just to this one. Okay, you plot x and y, then done. And then represents the object as a dot, okay, at the origin of the coordinate axis. And then this is a particle models. And then draw vectors represent each of the identified force. Right. So these are the 4 steps. And then usually I will add in one more step, which is step number 5. So what is step number 5? Step number 5 is you calculate, you solve the questions. Okay, you solve the questions. So step number 5 is you apply Newton's law and solve the questions. So remember, whenever it comes to these Newton's law questions, I will always encourage you guys to sketch free body diagram, even though the question didn't ask for the free body diagram. So now the first one, okay, if you look at this table, the keywords actually is located on the left-hand side of the table, where it tells you object is now at rest. Okay, now you have an object at rest. So why is it important to know that your object is at rest? Because it tells you which Newton's law to use. So now I have these two diagrams. I would like to call the students to answer the first question for me first. So first one, okay, I'm just going to follow the name list. Okay, yeah. Now I got one of you who accidentally switched on the mic, or you're the one that want to answer the questions. Who is it? Okay. So first one. Now let's look at questions 1. Okay, questions 1, how to solve it. I'm going to call the name according to the name list. Okay, I'm going to call the name according to the name list. So first one, Akram. Okay, Akram, tell me, what is the answer? Okay, you can either present it to the using the screen, or you can snap a picture and then post it in the group. I'll tell you whether it's correct or not. Okay, or you can even type it. Okay, now you can even mention it. Okay. So what is the answer, Akram? Let's see. So
Madam,
yeah,
yang free body diagram ni maksudnya kita kena lukis ataupun kita kena bagi tahu yang apa tu dia punya
force.
pun.
Kamu boleh beritahu saya dengan buka mic, atau anda boleh terus tunjuk saya gambar dekat Meet atau Telegram.
Baik.
Okay, so next one is Angeline. So you can prepare first, and then after that Bernice. Okay, and then followed by Fatima. So questions 1 until 4, 4 of you. Okay, so the other 3 you can prepare first. Okay, so Akram, let's see. So let me see how many questions do we have. So I just want to see a free body diagram, yeah? I just want to see free body diagram. So you just have to show me free body diagram. You don't have to show me the equations. I will teach you how to form equations today. So free body diagram, basically just a revisions. Okay. So just now I mentioned until questions 4, Fatima, and then questions 5, Govind. Question 6, Liu Wenchen. Question 7, Lim Siwei. And then I think I have 9 questions, if I'm not mistaken. Questions 8, Maizato. Okay, questions 9, Muhammad Adi. So you guys can prepare first. So we will present the answer straight away. So Akram, macam mana kamu nak present jawapan anda?
Saya cek sikit.
Semua ini, kelas kita bermula jam 8 tau. Saya dah suruh kamu buat tadi. Okay. So cepat-cepat, free body diagram sepatutnya boleh set dalam 10 saat.
Saya dah siap dah, tapi tu saya hantar kat
Okay, kamu hantar
Telegram.
dekat
Bit slow.
Oh, Telegram kamu slow. Okay. So kita tunggu jawapan anda, tengok betul atau tidak. Okay, I want to see whether you got the correct idea or not. Basically, you have to sketch the diagram for everything. Okay. Tak keluar lagi Telegram. So kalau tak keluar lagi, anda boleh terus beritahu saya. What is the answer?
Okay, jawapan saya macam tak bantu je. Okay, untuk jawapan saya yang apa tu untuk free body diagram tu, kena lukian panah tu ke?
Tak payah. So basically, you just need to draw 2 dotted axes. Actually, this is a better idea.
Oh.
Okay, so let's see. Let's say now I have the XY plane already. What should I do next?
Okay, satu anak panah hala kat atas. So untuk dia punya end.
Okay, good.
0. Lepas tu satu lagi hala ke bawah.
Okay.
Ada dalam satu line.
Okay, so
dia punya tu weight.
Alright, so itu saja.
Yes.
Yakin?
Yakin.
Okay, good. So let's see. So whether the diagram is correct or not, now let's see. So you have a object, and then according to the questions, it tells you object is not moving. Okay, so this object stays static where V is equals to 0. So if it is 0, means there's no force going to the left or going to the right. So what do you have? You just have a force going upwards and going downwards. And the answer, okay, how are we going to apply Newton's law? You look at the statement on the left-hand side. Object is at rest. So if you recall, okay, what we have learned in our lecture, if object is at rest, it means V is equals to 0. When V equals to 0, we apply Newton's first law. Okay, we apply Newton's first law. So Newton's first law, summations F equals to 0. So how are we going to apply it? Now you look at this diagram. What do we have? We have only y component. Therefore, we don't have to solve it for the x component. So y component, we have normal force going up, W going down. Therefore, we just use N minus W equals to 0. So what we are doing is just solving the diagram for the y component. Okay, for the y component. Therefore, if you rearrange the equation, N is equals to W. Right. So questions number 2. So I have the answer already. Okay, so Angeline PM me the answer. Let's see whether she got the correct diagram. So first, she gave me a force. Okay, now let me draw an XY plane first. So XY plane, usually we draw a dotted line to represent it. Now, sometimes it is very important to have this dotted line. Why? Because the questions will give you angle. Okay, so first vectors that she gave me is a force that is going into the diagram, the first quadrant. So correct or not? Yes, because of what? Because of the external force. Now, this external force is pointing toward object B. And if you remember, I told you in a previous lesson as well, if force can only come out from an object, it cannot goes into the object. Okay, it cannot move into towards the object. So what are you going to do? So this is your object. You let it come out from the other side. So the second vectors, okay, is a weight that is going down. So which is correct. So you have a weight going downwards. And then what else? So because the object is in contact with a surface, therefore you have a normal force. Remember, normal force always perpendicular to the surface. Okay, so this is still correct. Okay, now last one. Okay, last one she gave me. Okay, you guys don't follow don't draw the diagram first. Last one, she gave me a frictional force that is opposite to the F. Now, do you think it is correct? If you look at the diagram, does it make sense? Now, it doesn't make any sense. Why? Because if you look at the diagram, rough surface is a vertical wall. Okay, rough surface is a vertical wall. If you push this object, the object, it won't goes into the wall. What is going to happen? It will just move along the surface. So if you sketch your your frictional force that is opposite to your external force, then you got the wrong idea. Okay, so this is wrong. So you got one wrong answer in exam. What is going to happen? 1 mark will be deducted. So usually this is a 2 marks question. If you got one vector wrong, then 1 mark will be deducted. 2 vector wrong, then 2 marks will be deducted. Okay, so a frictional force, it won't comes out from the wall because there is no motion that is floating on the in the air. Okay, it's not floating. So what is going to happen is that now your frictional force should be going. Okay, now frictional force should goes up or go down. Okay, try to ask yourself, what happens if you push the object? If you push the object, by right, this object, it should goes up. The reason why it is not going up, because there is a frictional force prevent it from going up. Okay, so it's against the motions that you want to generate, you want to create. Okay, so in this case, we're going to draw frictional force that is going downwards, that is pointing downwards, because it against your intention. You want it to move up, but then it won't move. Why? Because there is a frictional force that is pointing in the opposite direction. So remember, frictional force can only be generated in between two surfaces. Okay, in between two surfaces. So it is not opposite to the external force. It is against the nature of the motion. Okay, it prevents the object from moving. So it will be lying on the line that is parallel to the wall, to the surface. So in this case, we have F along the vertical component. Why? Because we have vertical wall. So F is going downwards. So this is our free body diagram. Now, how are we going to solve the diagram then? We solve it according to its component. Let's begin with X component. Okay, let's begin with X component. Again, if you look at the statement on the left-hand side, object is at rest. At rest, again, we are going to apply Newton's first law. Okay, Newton's first law. So how many forces do we have in the diagram? Okay, how many forces do we have in our free body diagram? We have 4 forces. How many of them lying on the x component? The answer is 2. Why 2? Now, if you look at the diagram, the first one is a normal force. Normal force lying on the x component, therefore we don't have to resolve it. The second force that we have is a F. This F is lying in between x and y component. So when it comes to solving questions, applying Newton's law, what do you have to do is you need to resolve this F. Resolve it into x and y component, okay, so that you can solve it according to the component. So you resolve F into Fx and Fy. Okay, so Fx and Fy, they are the force that you want to substitute in the equations. So other than normal force, we have another force that is lying on the x component, which is Fx. So now we want to form an equations by using n and Fx. So n and Fx, they are pointing towards opposite direction. Fx is going to the positive direction. Therefore, we use Fx minus n, and it is equals to 0. So basically, you don't have to change anything on the right-hand side in the equations. What you have to do, you just expand the left-hand side. Okay, you just expand the left-hand side. So you look at the diagram and think, how are you going to expand it? So rearrange the equations. We have Fx equals to n along the x component. So second equation is according to the y component. So y component, what do we have? So y component, now if you look at the diagram, I have force Fy, okay, with the arrow, and then the frictional force and also W along the y component. So now I have 3 forces along the y component. So do I still have to look at this F? Not anymore, because I already resolve it into x and y component, okay, and then the angles here. So remember, Fx equals to n just now. So if you resolve it, if you expand Fx, it will become F cos theta equals to n. So let's look at y component. So y component, now I have 3 forces. So how am I going to solve it? Same concept. You use positive value minus negative value. So positive value is my Fy because it's going up. So summations F, now you always have to write summations F equals to 0 because it worth 1 marks in your exam. Just these equations, okay, before you expand it, okay, by just writing down summations F equals to 0, you already get 1 mark. So after that, you're going to expand the left-hand side of the equation. Look at the diagram. I have 1 force going up. So Fy is going up. And then I have 2 forces going down. So Fy minus the force that is in the opposite direction, which is Fy. And then another force, which is W. So you minus F minus W equals to 0. Okay. So if you rearrange the equations or you expand the equations, you're going to get F sine theta is actually equals to frictional force plus W. So basically, when you have situations where velocity is equal to 0, okay, either the object is at rest or the object is moving with constant velocity, then the force, okay, going to the right would be equal to the force going to the left. The force going up would be equal to the force going down. That is the ideal. Okay, so we are done with the first 2 questions. I give you 1 minute to copy the diagram and also the equation. If you have any questions, you may ask. Right, and then so now I have an answer for questions 4 in Telegram as well. So next, so Fatima, don't forget to do questions 4 and give me the diagram, or you can explain it to me after this, or you can present it with your camera. Okay. All right. So 1 minute for you to write it down before I proceed to next questions. So next question. Okay, so next questions. For these questions, we have two ways to sketch the diagram. Okay, the first one, of course, is according to the diagrams given. But when it comes to form equations, okay, I will teach you how to change the diagram a bit. So now let's see. You have a diagram, okay, object C, you put it on an inclined surface. Now again, if you look at the question, it tells you this object is now still at rest, right? It's still at rest here. So you have the statement on the left-hand side. So your friends already gave me the answer. Let's see how she draw it. Okay, so now you have this one is the inclined surface. Okay, and then this one, we take it as a y component. Okay, we take it as a y component. So, okay, the first force is the weight. Okay, so now you have a weight. So this is the object. Remember to put a dot here. Okay, to put a dot to represent the object. So this object, it has a weight. Good. So that is the correct answer. And then the second thing that friends give me is a normal force that is perpendicular to the surface area. Again, that is good. So this is a normal force. And then the frictional force. So frictional force, according to the diagram, okay, put it here. So that is correct. So this is a correct free body diagram. All right, so how do I know that the force is going up? Now, because I have a rough surface, and if you just put the object on this inclined surface, the nature of the object will cause the object to slide down. But now the reason why it's not moving, that is because you have a frictional force pointing in the opposite direction. Okay, therefore you have an F that is going towards opposite direction that prevents it from sliding down. So that is a complete answer. So now when it comes to a forming equation, okay, what are we going to do? Now we are not going to take a horizontal component as X, vertical component as Y. This would make it hard to form equation. Okay, so we don't want this. Okay, we don't want this. So what we want, okay, what we want in our diagram is now we are going to change our X component. Okay, we can make this surface, the inclined surface, as our X component. So it doesn't mean X component must be horizontal line, not. Okay, no. It depends on our surface. When you have an inclined surface, we take the inclined surface as the X component, and then the line that is perpendicular to the inclined surface as our Y component. Okay, so basically what we have right now, okay, now I'm going to rotate the axis a little bit when it comes to forming equation. So this is my F. So my F is now lying on the X component after I rotate my free body diagram. So now my normal force is going up, but then W is no longer going down. Okay, W is lying in between X and Y component at an angle theta. Okay, so this theta, okay, this arrow, this theta, I have it, okay, I have it beside X component. Okay, so if you look at the diagram now, let's go to the diagram on the left-hand side. So how do I know my theta is located beside the x-axis? Now, let's see. This is my X component. This is my Y component. Okay, this is my Y component. So if I have weight, okay, if I have a weight, now I'm going to take this, okay, I'm going to take here as my origin. Okay, I'm going to take here as my origin. So what is going to happen? Now I have object. So let's say my frictional force is going up, and then my normal force is going perpendicular to the surface. So W is going down. So if you look at W, this W is perpendicular to the horizontal line. Okay, it's perpendicular to the horizontal line. So what does it mean? It's actually giving us a diagram, okay, a triangles here. So these triangles tell us what? Okay, these triangles, it gives us a total of 180 degree. Okay, a total of a 180 degree. So now if you look at this diagram again, if this is a 90 degree, then it means, so not 90 degrees, sorry, this is theta. So it means this angle beside x component is 90 minus theta. So the angle beside y component is also equals to theta. Okay, so if you enlarge this part, let me redraw it again. So what you have here is a triangle. Okay, now you have a triangle here, a right angle triangle. So right angle triangle, it tells us that the total angles in the object is 180 degree. So right angle triangle, this right angle already take up a 90 degree. So given the inclined surface, inclined at angle theta above horizontal line, so which means angles beside x-axis. Okay, angle beside x-axis is 90 minus theta. So angle beside y-axis would then become theta. So my theta should be here. Okay, so I made a mistake just now. So this is a theta. So inclined surface give you a theta, and this theta is located beside y-axis in our diagram. Okay, the reasons why, because if you look at the diagram, W form a right angle triangles with the inclined surface. Okay, so by using the angles rules in your mathematics, you then can identify this theta is actually equals to the angles beside y component. Okay, because x and y component give you 90 degree. Okay, it gives you 90 degree. So if W is here, okay, then it gives you angles from x to W. Okay, for angles from x to W is 90 minus theta. Therefore, angles beside y is theta. Okay, angle beside y is theta. So basically, that is what happens in our diagram. So make sure you need to know how to determine the diagram, because the diagram itself, okay, the angle itself plays a very important role in our calculations. Without correct angles, then basically you are going to get 0 marks in your calculations. Okay, without correct angles, you're going to get 0 marks in your calculations. So now that I rotate my free body diagrams into the green color free body diagram, so what am I going to do? I'm going to resolve it into x and y components again. So x component, okay, now x component, I'm going to take the one lying on the horizontal line. So x, what do I have? Now, if you look at W again, it's lying in between x and y component. So which means now the force that you need to resolve is W. So Wx, and here you have Wy. So for x component, again, summations F equals to 0 because it tells us object is at rest. And then F is positive force now, frictional force is positive, minus Wx equals to 0. So Wx in our case right now is F equals to W sine theta because angle is located beside y-axis. So for y component, basically you just repeat the same thing. Summations F equals to 0. So if you look at the diagram, now I have two forces along y component. So which is N and Wy. So N is going up, therefore I use N minus Wy equals to 0. And N is then equals to W cos theta because now my angle is beside y-axis. Okay, my angle is beside y-axis. So that is questions number 1. All right. So next is the questions number 4. I have the answer as well. Let's see. So questions number 4. Okay, questions number 4. Right. I have diagrams like this. So your friends, Fatima, gave me the diagram like this. Let's see. So now this is our x component. This is our y component again. So this is the object. So remember to use a dot to represent the object. So if you look at the diagram, now you have 2 strings. Okay, so your friends give me 2 T. Okay, so good, Fatima. So first T is going to the right hand side, and then second T is at an angle. Okay, second T is located as an angle. Okay, so there's only one mistake in your diagram. Okay, there's only one mistake in your diagram. Now you label both tension as T. it is wrong. Why? Because now you are looking at two different strings. You have a string number 1 that is lying on the x component, and then you have a string number 2. So you are looking at two different strings, therefore you need to add a subscript. So without subscript is also considered as wrong. Why? Because you're assuming both of them they have same magnitude. So when it comes to this type of question, remember to put subscript. So let's say this is T1 and this is T2. Okay, so for the one lying on the x component, I label it as T1. So for the ones that is located in between x and y component, that is going to work northwest, so I put a T2 here. Okay, so remember, you need a subscript. Without subscript, it's considered as wrong. So that is the only mistake in your diagram. So next one, what do you have? You have W. So W going downwards. Good. Okay, so your friends got a W going down. So basically that is a complete answer. Okay, and then it's up to you, because now these questions, okay, you are not given any angles. So what should you do? You just you just put an angles here. All right, it's up to you whether you want to put the angles on the left hand, on the x-axis or on the y-axis. So this is a complete free body diagram. Okay, this is a complete free body diagram. So this is a questions without normal force. Why? Because it is not in contact with any object. Okay, it is not in contact with any object. Okay, so again, I want to solve the questions, but before that, I need to resolve T2. So let's resolve T2. Now, in exam, what should you do? In exam, you can sketch the diagram with pen, and then you resolve with pencil. Okay, you don't resolve with pen. If you resolve with pen, okay, I'm afraid that they might treat it as another 2 additional force. Then you're going to get the wrong answer. All right. So you sketch the diagram with a pen, and then you just resolve with pencil. Okay, so this is your T2 along the y component, and then this is your T2 along x component. So T1, T2, and W you sketch with pen. T2x and T2y you just do it with a pencil. So let's resolve x component. So x component, again, I have summations f equals to 0. So summations fx equals to 0. Then what is happening along x component? X component, T1 minus T2x equals to 0. Okay, so T1 is equals to T2 cos theta. So cos or sine depends on the locations of the angles. Whereas when it comes to a y component, okay, so y component, summations, now would be better if you put the fy here, okay, because most of the time students tends to forget about the x component and y components. So biasanya pelajar dia tak suka tulis x component, y component, okay, tak ada masalah, janji kamu letak subscript y di dalam kamu punya first law. So summations fy equals to 0 according to my diagram, I have T2y minus W equals to 0. So rearrange the equations, I then have T2 sine theta equals to W. So this is the answer. All right, this is the answer. So now again, I give you 1 minute to write it down. Okay, I give you 1 minute to write it down. So you write down the diagram, and then you write down the equations. All right, so you should have tried it before class. Okay. So make sure to ask if you have any questions, if there's anything that you don't understand, ya. So tanya kalau ada apa-apa yang kamu tak faham.
Madam, I have a question.
Yes.
Why is there no end?
Why is there no end? Because it's not in contact with any force, right? It's not in contact with any surface. So if you look at the hints that I give in the 5 questions that I ask you to ask yourself whenever you're solving a Newton's law questions. One of the question is the object in contact with any other surface? Obviously, it's not, right? So if it's not in contact with any other surface area or any other object, means there's no reaction force, there's no normal force.
Okay.
Right. Okay, so we are done with the questions number 4. Now let's look at questions number 5. This question is slightly more complicated. Why? Because now you have two objects, object E and object F. So how are you going to sketch free body diagram? Now you must sketch it separately. Okay, you must sketch a separate diagram for a different object. So again, now you have object that is at rest. So what am I going to do? Okay, now let me check your friend's answer. So Govin's give me a diagram. Okay, and I would say it's incorrect. Now, why incorrect? Okay, let's see. Right, you don't write down the answer yet. I'm just going to give you the diagram from your friends. So your friends tell me, okay, this is T1. Okay, this is T1. And then this is N. And then this is T2. So for object 1, that is for object E, that is the answer from Govin. And then for object F, okay, if I look at the diagram, so Govin just give me a force that is going down. So if you look at these two diagrams, do you think it is correct? I don't think it's correct. Why? That is because if you look at a diagram for object E, why is there an N here? It is not in contact with any other object. It's not touching any surface. So this is the first mistake. The second object, now it's being hung by a string. But then there's no tensions. I didn't see any tensions. So again, it is wrong. Okay, it is wrong. So both diagrams are wrong. Now in exam, because now you have a 2 or more mistake, so straight away you are going to get 0 mark in the vector questions. So usually vector question is worth 2 marks. Okay, 1 mistake minus 1 marks, 2 mistakes straight away 0 marks. So even if all the other diagrams they are all correct, you still won't get any marks from it. Okay, you still won't get any marks from it. So how are we going to sketch a free body diagram for a case like this? Okay, so the idea from Govin is correct. You need to draw 2 free body diagrams, just that he puts the wrong force in the diagram. So let's begin with object E. Okay, object E. So object E, I have a free body diagram, so I use a dot to represent the object. Now, if you look at the question, first it is being hung by a string that is coming from the wall. So remember, tension always leaves the object. Therefore, I have T1 going up. Okay, I have T1 that is going upwards. Again, if I look at the object, okay, now E itself is an object. Every object comes with weight. That is what I told you before. So whenever you have object, so basically every question, okay, there must be a weight because there is an object. So every object comes with weight. So this is weight for object E. Okay, because now you have 2 objects, therefore for E, you need to include its subscript. Okay, for E, you need to include its subscript. So WE is going down. Now, if you look at the diagrams again, other than the strings from wall, now there's another string that joins, that connect object E and object F together, which means there should be another tension, okay, below object E, because there's another string. So therefore, I have another tension. So I just need to continue the arrow. Okay. So this is my second tension, D2. So I have a WE, I have D2. So that is a complete free body diagram for object E. Okay, for object E. Now let's look at object F. Okay. So object F, again, free body diagram is a dot object. So now you have an object. Every object comes with weight. So I have W, F that is going downwards. Okay, WF that is going down. And then if you look at the diagrams again, what is happening here? Now you have a strings that is joining F and E together. And remember, my tension must be leaving the object. Therefore, I have another T that is going up. So remember, you need to put a subscript here. So this is T1 or T2. Let's go back to the diagram. Now the string that is joining the wall and the object E, we labeled as string 1. The string that is joining object E and object F, just now we labeled as a number 2 string. Therefore, for object F, the T should come with a subscript T2, okay, because it refers to the string in between E and F. So when it comes to this type of questions, we can join these two diagrams by using T2, okay, because T2 in an object E and T2 in object F, both of them, they have same value. So you can use simultaneous equations to solve the questions if you need to combine them together, combine these two equations together. So now let's do a free body, let's do equations for them. If you look at the diagram, now you have force only on the Y component. So you don't have to do for the X component. All right, and now since object is at rest, so summations Fy is equals to 0. Right, so for object E, I use red color, summations Fy is equals to 0. So how am I going to form equations? Now I have a T1 going upwards. So minus WE and then minus T2. Okay, minus T2, which is then equals to 0. All right, which is then equals to 0. So let me rearrange the equations a bit. So if you need to join these two equations together, these two diagrams together, then you let T2 sitting on the left-hand side. All right, so T2 is equals to T1 minus WE. So let's leave it first. Now let's look at the equations for object F. So summations Fy is equals to 0. Right, now I have only two forces, one going up, one going down. Straight away, you know, T2 minus WF is equals to 0. So T2 is now equals to WF. So now if you look at these two equations, now both of them, they have T2 on the left-hand side. Okay, you can then do a simultaneous equations if needed to. If you need to join these two equations together, then this is your equations 1. This is your equations 2. Okay, you can then sum up equations 1 equals to equations 2. Therefore, T1 minus WE, okay, is actually equals to WF. That's it. Okay, so that is how you simplify. That is how you solve the questions that involve more than one object. There must be something where you can use to join them together, to join both equations together, right? So I give you 1 minute to write it down. If you have any questions, you may ask. Okay, before we proceed to a next situation where object is moving with constant velocity. Okay, so this is the last example for object at rest. So if you have any questions, make sure to ask. Okay, so I have a question number 6, answer for question number 6 ready in the Telegram. So 7 and 8, don't forget to give me the answer as well. Okay, so 7 and 8. 7 is a Sway and then 8 is a Maisato. Okay. Semua yang segan, semua PM tepi. Next time post sahaja dalam group, okay? Because it's your group mate. Tak payah segan. Alright. So done. Alright, next, what are we going to do next? So now your object is moving with constant velocity. Okay, so if you look at the statement on the left-hand side, object is moving with constant velocity now. Okay, so constant velocity, now why is it important to know that the object is moving with constant velocity? If you recall the conditions in Newton's law, If object moving with if object moving at rest, not moving, sorry, if object is not moving, if object is at rest, v equals to 0, we apply first law. And the second possibility is if your object is constant velocity, moving with constant velocity, okay, we also apply Newton's first law, summation F equals to 0. So it is very important to check the informations given, to check the conditions given in the question. So given constant velocity, so we know that we have to apply Newton's first law in our calculation. Okay, so now we still have a constant velocity. So how to sketch the diagram? Okay, how to sketch a diagram. So when it comes to these types of questions, okay, now let's check. So okay, so now your friends give me an XY plane. So X plane is the surface area, is the inclined surface, and then Y is perpendicular to the inclined surface. So that is good. So you got the first correct diagram already. And next, okay, next give me, okay, so Wenchens give me T going up. That is correct because now you have a string, so you have a tension that is going up. And then, okay, okay, you have a normal force that is perpendicular to the surface. Good, okay? So this is a normal force. All right, the next one, okay, next one, Liu gave me W going down. So that is correct. With a theta beside y-axis. So good. So you must show this angle, okay? Whenever the angles is being stated in the diagram, is given in the diagram, you need to show it in your free body diagram. Okay, so kalau soalan bagi anda angles, then you need to put it in your diagram. That is the rules. All right. So don't have to ask me, Miss, do I have to include the angles in my diagram? It's based on the question. If you are given the information, then yes, you must put it in your diagram. If you don't have the information, then you just put a theta there without the value. Okay, kalau tak ada nilai, then you just leave it. Okay, now, your friend give me another force called frictional force in the diagram. Is it correct? Should you put Fk here? Actually, you shouldn't put Fk. Why? Because questions doesn't tell you smooth or rough surface. Okay, if the questions didn't mention a smooth or a rough surface, then we assume it is a smooth surface. Okay, this is the assumption. If questions didn't mention rough, if questions didn't tell you there's a frictional force, if you are not given coefficients of friction, then we assume the surface is smooth. Therefore, we don't have to draw, okay, we don't have a frictional force in our free body diagram. So there's a mistake in your answer, all right? So make sure to correct it. No frictional force. Why? Because question didn't say anything about the surface. It didn't tell you the surface is rough. Therefore, we assume it is smooth. So this is I would say is what we call default setting in your game. So default setting, smooth surface, unless the question tells you, okay, otherwise you assume it is smooth. So done, this is our diagram, okay, this is our complete diagram. And when it comes to questions like this, usually I will encourage my students to put this V in your diagram. So how to put V in your diagram? Now, usually I will just put it outside the free body diagram. So this is the directions of motion. Okay, so biasanya saya akan tambah arah ini because it's useful when it comes to calculations. Okay, especially when your object is not moving with constant velocity, then this arrow plays a very, very important role in our calculation. Okay, so now that I have an inclined surface, I'm going to use this inclined surface as my x component, and then the component that is perpendicular to the inclined surface as my y component. So again, I'm going to form equations for x component. So x component, I have tensions going to the right. And then what else? So if you look at the diagram, the force that I need to resolve is which one? is W, because W is lying in between X and Y component. So I'm going to use pencils to sketch it. So this would be my WX, and then here would be my WY. Okay, here would be my WY. So I have a tension that is going to the right, and then WX that is going to the left. So this is a free body diagram for X component. Okay, so what am I going to do now? Oh, you don't have to sketch it, yeah? I'm just showing you because now I want to form equation. Okay, this one you want to sketch it or not, it's up to you. Okay, I just showed you because I want to form equations. So summations fx is now equals to 0 because object is moving with constant velocity. So t minus wx equals to 0. Therefore, t is equals to w sine theta. Okay, t is equals to w sine theta. So now what do I have along the y component? So for y component, I have a normal force that is going up, and then I have a wy that is going down. Okay, so again, you don't have to show this diagram anymore. What you need is just a diagram in here, okay, in the middle column. So diagram in the last column, I just explained it to you how to obtain the equations that I'm showing you now. So summations Fy equals to 0. Along y component, I have only two forces. Therefore, n minus Wy equals to 0. And my n is equals to W cos theta, because angle is beside y component. Okay, angle is beside y component. So that's it. Okay, that is our equation diagram and also equations. Okay, so remember, if you have a question that just asks you to sketch free body diagram, you don't show resolving vector in your diagram. Okay, you just show the resolving with pencil if you need to resolve the questions, if you need to do calculations, right? So 1 minute for you to write it down before we proceed to the next questions, where object is now moving with constant acceleration. Okay, where my object is now moving with a constant accelerations. So 1 minit bagi Anda. Kalau ada sebarang pertanyaan, Anda boleh tanya. Okay, so next. Okay, so next, now if you look at your notes, okay, if you look at your notes, now it tells you object is moving with constant acceleration. Okay, so constant acceleration, this is what we have right now. Let's see how are we going to sketch a free body diagram. So free body diagram, you're still going to sketch with the same method. All right, if you have one object, then you sketch one free body diagram. If you have two objects, then you sketch two free body diagram. So let me sketch the diagram from your friends first. You don't do anything yet, okay, because there's a mistake. Okay, so what do I have right now? I have okay, so your friends give me, this is a diagram for object G. Okay, so you have a force going to the right, and then you give me this is a N, and you give me this is WG, and then this is your object H. So object H, let me see. Okay. So Siwei give me basically the same diagram, but then with a different subscript. So this is a N, and then this is a WH. Okay, so this is the answer from your friends. Okay, this is the answer from your friends. Okay, so got a dotted line to show that this is the x-axis. Now these two diagram, I would say it's incorrect. Aha. Why incorrect? Both of them, they are both incorrect. First of all, you look at F. This capital letter F. This capital letter F is only touching object G. So how do you have, okay, how can you draw a F for your object H? There's no external force acting on object H, right? It is just an object, it is just an external force, okay? The external force is just a touching object G, okay? Directly in contact with object G, not object H. Therefore, you shouldn't have this F here. And the second thing, now we say reaction force exists when object is touching each other. If you look at the diagram, now object G is touching object H. Aha, so this is the part where students always got a mistake. Okay, this is a touching point. Okay, the place they are in contact with each other, it tells us that there is a reaction force in between two objects. Okay, so why object H can move? Object H is moving because of the force coming from object G, not this F, not external force. Therefore, okay, therefore, what do we have? We have FG that is going to the left, okay, at the point that they are contact with each other, they are touching each other. So G is pushing object H with FG, and at the same time, because they are in contact with each other, according to Newton's third law, okay, object H will push object G back with the same amount of force, but then in the opposite direction. So that is the force that is missing in your diagram, okay, Siwei? So now let's see. How am I going to draw it? So both diagram, they are incorrect. So let's begin with object G. So object G, now I have a X and Y plane first. Okay. So first of all, now you have an object. Whenever you have object, okay, there must be a weight, so it is a good. So you got show me this, WG. And then this object, you place it on a surface. Therefore, it comes with a Newton force. So this is another mistake that you make in your free body diagram. Normal force, now you're looking at different object. Therefore, this normal force should also come with a subscript. Because object G and object H, they will have different normal force. Why? Because normal force is being affected by the mass of the object. And apparently, G and H, they come with different mass. Okay? So you will have different N. Therefore, you need to include the subscript. Right? Therefore, you need to include subscript. All right. So second force is Ng. Now, third force. If you look at the diagram, this external force F is directly in contact with object G. Therefore, we are going to put it in an object G here. So we have a force, external force that is going to the right-hand side. So this is correct. And at the same time, because it is in contact with object H, okay, when you push object G push object H. And at the same time, object H will exert the same amount of force and push object G back in the opposite direction. Therefore, I have FH in the opposite direction. So this is a complete free body diagram for object G. Okay, a complete free body diagram for object G. Now, how about object H? So object H, again, object H is an object. Every object comes with weight. So you put a weight here. So this is WH. And then you put it on a surface. Therefore, now you have a normal force. So normal force and H. You need to put a subscript here to indicate that this N is only for object H. And now, if you look at the diagram again, external force is not directly in contact with object H. Therefore, we don't put F in our diagram. Okay. Now, so what is the reason that object H can move? Because it is being pushed by object G. Therefore, we have FG here. Okay, we have FG in our diagram. So that's it. That is a complete free body diagram. Okay, that is a complete free body diagram for object G and object H. And remember the things that I told you just now? I would like you to put A in the diagram as well, but not in your free body diagram. You put it outside free body diagram to show the directions of motion, right? To show the directions of motion. Now, why? Why do we want to use A? That is because we want to use it to determine the directions of a positive value. When object is moving with constant acceleration, now we need to change the rules of a sign conventions a little bit. The directions of A, we are going to take it as a positive direction. Okay, so the other side, of course, the other direction would be a negative direction. So direction A is a positive direction. So the tail of the arrow is a negative direction. All right, arrow is positive, tail of the arrow is a negative. So we are going to take, so according to these questions, we are going to take right-hand side as our positive direction. If you have A going to the left-hand side, then we are going to take left-hand side as a positive direction. All right, so that is a special things in Newton's second law. So since your object is now moving with constant A, so we want to apply Newton's second law, summations F equals to MA. Okay, so for object G, okay, let's begin with object G. So object G, what am I going to do? So I need to form equations for X and Y component as usual. Okay, so X component, summations Fx equals to, now it's not equals to 0 anymore, it is equals to MA. Okay, because object is moving with constant acceleration. So what am I going to do? Now I want to expand the left-hand side of the equations. So you just leave the right-hand side. So right-hand side is always equals to MA now. You don't have to do anything about it. Okay, just that you have to be careful because now you're looking at object G. So M for object G, MG, A. Okay, put a subscript here. All right, now along the X component, okay, I have two forces and now I'm going to take right-hand side as a positive. So F minus FH equals to MA. So this is our first equation for the X component, right? And then for Y component, summations Fy. Now the object is not moving along Y component. Your acceleration is lying on the X component. Okay, so for Y component, we apply Newton's first law. Because our object is not moving up and down, there's no motions along vertical component. Okay, you have motions only along X component. Therefore, X component, you use MA, and Y component, you use equals to 0. So expand Y component. So now I have a NG minus WG equals to 0. Okay, therefore, NG equals to WG. That is for object G. Okay, that is for object G. Now I'm going to repeat the same thing for object H. So object H, summations Fx, now X component, now acceleration is lying along the X component. Therefore, MHA. So what am I going to do? MA, you just keep it. Okay, you don't have to do anything about it. So let's see how am I going to expand the left-hand side. If you look at the free body diagram, you have only one force. Therefore, okay, Fg is straight away equals to MHA. Okay, MHA. So this is for X component. So again, for Y component, summations Fy equals to 0. And then we have NH minus WH equals to 0. Therefore, NH equals to WH. So again, we use different law for different component. Why? Because my object is just moving along the x component. Therefore, Newton's second law for the x component. There's no motions along y component. Newton's first law for the y component. Okay, object is not moving up and down. So how are we going to join these two set of informations together? We can join them together by using Newton's third law. Okay, Newton's third law tells us what? It tells us Fg is equals to negative Fh. So they have same value, just that they are pointing towards opposite direction. Okay, so the reasons why we know they have the same value, because they are the contact force. Okay, object 1 or object G and object H, they are in contact with each other, and this force exists because of the point in contact between these two objects. Okay, so same amount of force are being exerted on both of them, just that the force is heading towards opposite direction. Okay, the force coming from H will push object G backwards. The force coming from object G will push the object H going forward. So this is how we form the equation for object G and H, and how we join them together, which is by using Fg and Fh, right? So now I give you 2 minutes to write it down. This is very important, and this is the part where students always make mistake in their exam. So make sure you go through it carefully and then ask if you have any questions. 2 minutes from now for you to write down the answer.
Madam, I have a question.
Yes?
Why did you include H in object H, free body diagram?
My free body diagram, where I got FH? My free body diagram is FG, right?
But then you said equal force.
Yeah, equal, because this is a contact force in between F and G. Now you look at the original diagram. Isn't that I put a dot there? So this is actually what happens here. So when you push object G will push object H. But because some of the forces, are gone, all right, because of some of the external factor, therefore the force exerted on object H is not the original external force anymore. So we use a contact force between object G and object H.
So we don't include the contact force from H in our body diagram, is what you meant, is it?
No, we don't include this external force in our free body diagram for external for H, in our object H.
I don't get it.
Now you look at the diagram, you look at the original diagram, external force, capital letter F. It just has a direct contact on object G. It doesn't touch object H. So you shouldn't include external force F in your object H. But then your object H can move. Why? It can move because it is being pushed by Fg. It's being pushed by object G. Therefore, you include Fg in your free body diagram, but not F. But when it comes to object G, object G, external force is being acted directly on object G. Therefore, you have a capital letter F in your free body diagram. And then this object G, it cannot just move freely. Why? Because there is something stopping it from moving, which is object H. And when your object G is in contact with object H and you push it, at the same time, this object H will stop your object G from moving, right? So therefore, you have a force coming from object H. This is the force that is trying to stop my object G from moving. Therefore, it's opposite to the original force, the original external force. And
but as you said, there is a force coming out from H, right?
Exactly. This is your FH, because it's trying to stop your object G from moving. That is because of your Newton's third law. Like what I explained in a previous lesson. If you have a wall, and then this is you pushing the wall. Now you push the wall. When you push the wall with 10 Newton of force, actually at the same time, the wall is pushing you back with another 10 Newton of force. That is what happens in Newton's third law. Whenever you have two objects in contact with each other, same amount of force will happen on both of them, but in the opposite direction.
But we don't include the opposite opposite direction force in the body diagram.
In which body diagram? Which force? Now you're talking
you see the Fg is included. But then you see there is, of course, as per Newton's third law, there is an equal and opposite force in opposite direction pushing. But
Mhm.
why is it not drawn, like in the sense that FH is not, why is it not on the left side of the body diagram drawn?
Now,
Opposite, is it oppositely?
now you go back to the definitions of free body diagram. Free body diagram, what you're looking at is the force acting on the object. That is the main thing in our free body diagram. It shows you all force acting on the object. Now this FH is being generated by object H. It is not being acted on object H. That's why you don't include in your object H free body diagram. It is the force generated by H, not the force acting on H. The force FH is being acted on object G. Therefore, we put it in object G free body diagram.
Okay, all right.
All right?
Okay.
So make sure you are clear, yeah?
Yeah, because as you said, it's not one of the force that is acting. It's actually the result of the force that is coming as the result of the force acting. Yeah, okay, I get it.
Okay, good. So this is your questions. Questions ke berapa? Question 7. Okay, so make sure to write it down, make sure you understand, and make sure you remember free body diagram refers to the force acting on the object. If it is the force generated by the object, you don't include it in its own free body diagram. Okay. So you have object G, object H, and then you can join these two objects together by using Newton's third law. Okay, so questions. All right, next. Questions 8. So questions 8, again, we have two objects. So which two object I? Okay, so we have an object I and also an object J. So what are we going to do right now? Let's see the answer from your friends. Okay, so Maisato gave me a 2 diagram. This one, okay, she gave me this is a T. And then you have a NI, good. Okay, so she managed to did a correction while I'm explaining a previous question. So another one, okay, because of a rough surface, so a frictional force going to here. And then this one, Maisato gave me object J. Okay, so this is a F. So this is a force. And then this is a T. And then again, she gave me a... Okay, so this one should be N2. NJ, not N2. Okay, NJ. And then this is a WJ. So yeah, that is good. Okay, so this is a correct free body diagram. So first of all, if you look at the diagram, now you have only one string, which is a string joining I and J. Okay, the string joining I and J. So this is the tension. So you have only one string, therefore tension, you don't have to put subscript. So for object I is an object, and then it has a weight going downwards. And then N is going up. Okay, N is going up, and because you're pulling the object, and object, now this one, okay, you know that the tension is going to the right. Frictional force, it depends on the directions of A. A is going to the right, therefore F is going to the left. It's opposite to A. Okay, frictional force always opposite to A. So for second diagram, okay, now the external force, this F is directly being acted on the object J only. Therefore, F, you put it in a J, okay, on J, not on I. I, it moved because of the tension, not because of this F. Okay, so F is a force acted on object J. So we put it in a free body diagram for object J. So object J, again, is an object, therefore it comes with weight. And then it is being placed on a surface, therefore you have NJ. And then behind it, there's a string. And this string is pulling object I. So you have a tension. And one force is missing. Now, for object I, you also include frictional force because of the rough surface. But don't forget, object J is also being placed on the same surface. Therefore, there should be another frictional force, F, okay, in your diagram. And these two frictional force, they have different value. Okay, they have a different value. So this is your Fi, and then this is your Fj. Okay, this is your Fj. So Fi and Fj. My J. Okay. So why F? You need to include subscript because if you remember, F is equals to mu n. Okay, the normal force. Okay, and then N is equals to mg. So it all depends on mass. All right, therefore F can also be written as mu mg. So they all depends on the mass of the object. If you have different object with different mass, then frictional force would be different as well. All right, even though you have the same coefficients of friction, but now because the mass is different, therefore frictional force is different. So let's look at the equations for object I and then object J. So before you form equations, like I told you just now, you need to determine the directions of A. So A is going to the right, A is going to the right. Therefore, what am I going to do? I'm going to use right-hand side as a positive direction, left-hand side as a negative direction. Okay, so this one is still very easy because it follows the directions of a positive direction of a vector that we have been doing in the last few chapters. Okay, now object I. Object is moving with constant acceleration. Therefore, I'm going to use Newton's second law. So summation Fx equals to MIA. Okay, the mass of object I times the acceleration. Now, these two objects, because they are being joined by the same strings, they are moving together. So both of them, they have same acceleration. So you don't have to put subscript in the acceleration. Okay, subscript, you only put it in the mass because now you're looking at different object. So let's expand the x-axis. So x-axis, I have tensions and frictional force. So T minus Fi equals to MIA. So done. This is my first equation for the x component. Let's do equations for y component now. So summations Fy now, because there's no motions along y component, against it is equal to 0. Therefore, I have Ni minus Wi equals to 0. Okay, Ni minus Wi equals to 0. So that is the equation for y component, x component and y component along the object I. Okay, next, again, I'm going to do a same thing for object J. So object J, again, summations Fx, but now is equals to Mja. Okay, Mja. So for the x component, now I have three forces on the x component. Therefore, I have capital letter F, which is the external force, minus tension, minus Fj equals to Mja. So this is my second equations. And then y components, again, same thing is going to happen. Summations Fy equals to 0, and J minus Wj equals to 0. Now, how are we going to link these two equations together? Okay, usually when you have this type of questions, they like to ask you to combine the equation from two different objects together. How are we going to join them together? By using simultaneous equation. So let's look at the equations in blue color. Equations in blue color, there are two components, there are two variables without subscript. So it means for object I and object J, the tensions and the A, they are equal. Okay, so you can solve it by using simultaneous equation. So you use these equations And this equation, you use simultaneous equations. Persamaan serentak. Okay, simultaneous equation. Tahu? Penyelesaian persamaan serentak. Because now you have two equations with two same variable. Okay, I would rather call it two unknown. Usually tensions and A questions won't give you. It will ask you to find it. So how are you going to find it? This is how you do it. You form equations for X component. You form equations for Y component. Then from there, you use a simultaneous equations to find T and find A. Okay, so this is a very common sense questions in exam. Alright, soalan yang agak kerap kita jumpa dalam exam, di mana Anda kena buat dua equations and then guna persamaan serentak untuk menyelesaikan equations dari objek I dan juga equations dari objek J. Biasanya kena guna kedua-dua equations serentak. So I give you 2 minutes because this is very important questions. I give you 2 minutes to solve it. Okay, to write it down, including the diagram. Okay, so kalau dapat yang tak faham, pastikan Anda tanya. Okay. So next one. So now these questions is a bit tricky now because you have object and two of them, they're moving in the different directions, right? In different directions. Now let's see a free body diagram from your friends first. So object, now you have two object. So object L and then the object M. So object L, this is a free body diagram. So Eddie gave me a T. Okay, Eddie say this is T1. And then WL. Then NL. This is a N, L, and then a rough surface. You got a friction. Good. Okay, and then a object M. So you have a WM, and then you put ST1 again. So if you have same T, basically you don't need subscript. Okay, you just write a T. Now if you want to put subscript, it doesn't matter. Okay, also can, don't worry. So two of them, they have a T. So this is a correct free body diagram. So good, Eddie. So this is how you draw free body diagram. So object L, now because you have a tension, so you have a string, so therefore you have a T going to the right hand side. And again, questions mentioned rough surface. So rough surface means there's a frictional force. Every object comes with a weight, so you have a W going downwards and N going up because you put it on top of a surface. It is in contact with a surface. And for object M, W is being hung by a string, and this string is same as the strings that join that pulls object L just now. Okay, so basically you have just one string in the diagram, therefore you use the same tension. So which means this T is a thing that is going to join both of them together. And then a WM going downwards. There's no normal force because it's not in contact with any other object, right? And then now what is important is A. So A for object L is going to the right. Therefore, we take a right hand side as positive and left hand side as negative. But when it comes to object M, by common sense, if L is going to the right, then M should be going down. Therefore, your A should be going downwards. When your A is going downwards, what is happening? Now, we are going to take downwards as our positive direction and upwards as a negative direction. Okay, because we don't want to modify equations of a Newton's second law, so we change the directions of sign convention. So let's see how are we going to form equations. So for object L, okay, for object L, so X component, again, summations Fx is equals to MA because A is moving along the X component. So ML A. X component, I have two forces, so T minus F equals to ML A. So this is the equation for the X component. For the Y component, because my Y component is not moving, so Fy is equal to 0. Therefore, NL minus WL is equals to 0. So this is our equation from object L. Let's look at the equations for object M. So object M, okay, what is happening is the object M. Again, object M is moving with an acceleration. But now, object N is moving along Y component. Therefore, summations Fy is now equals to M, A. Okay, so for object M, Y component is the one with acceleration. Therefore, for Y component, we apply Newton's second law. Now, how are we going to expand it? If you look at the diagram, now I say downwards is a positive direction. Therefore, W is a positive value. Okay, so when I expand it, I'm going to use WM minus T equals to MA. So this is how I solve it. Okay, this is how I form the equation. So I use WM minus T equals to MMA, right? Equals to MMA. So in some books, you might still see T minus W, but they use negative MA, okay? Nothing's wrong, okay? Nothing's wrong. Both of them, they are accepted. My method, I use direction A as positive direction. Okay, some of the books, what they did, they use, they say because A is going downwards, they use summations Fy equals to negative MMA. So for me, I don't like to use negative equation because it will make students confused. Okay, when to put negative, when not put negative. So it's very confusing. If you use negative equations, then the equations will become T minus W equals to MA. But I don't like this one, okay, because it's very confusing. So what am I doing? I use directions A as positive direction. So it doesn't mean that the formula in green color is wrong, okay? Some of the lecturers, they like to use the one in green color. But for me, I think it's confusing because sometimes students, they get confused when to use negative MA, when to use positive MA. So I think it would be better to stick to just MA so that you know you don't have to change anything on the right hand side. You don't have to edit the equations on the right hand side. Right? Tak payah buat apa-apa pada sebelah kanan. So sebelah kanan always MA. Okay, sebelah kanan always MA. You don't have to simplify it. You don't have to change the sign conventions. What we do, we just change the sign conventions on the left-hand side of the equation, right? By using A as our positive direction, right? So this is how you solve these questions. So again, I give you 1 minute to write it down. So again, these two equations can then be joined by using T because they have same T. Right? So untuk soalan yang ada dua objek, biasanya mesti ada sesuatu yang boleh join mereka together. Can join them together. You just have to identify which variable. So T and also A. Okay, T dengan A dia masih nilai yang sama. So again, simultaneous equation. So 1 minute for you to write it down before I proceed to the last 3 questions. Or last 4 questions. Okay. All right, next. So now you have 2 objects again. Okay, now this involve a pulley. So remember, pulley again, it's being joined by the same string. Okay, you have the same strings that move over the pulley. And again, if the questions didn't mention anything about pulley, we assume it's frictionless. So no frictions across the pulley, right? So what happens right here is that now you have one string that is joining them together. So this string, so means you have only one tension. And then your object Q is moving up, which indicate that object P is moving down. So this is a thing that you must know before you sketch a free body diagram. So now let's begin with a free body diagram. So for these 2 objects, it's very simple because there's no X component. What you have to do is just for the Y component. So object P, this is the object. Object P, every object comes with a weight. So W is going down, so WP. And then it's being hung by a tension, a T, a string. So T going up. And for object P, my A is going down. Therefore, what am I going to do? I'm going to use downward as a positive direction, upward as a negative direction. So for object Q, okay, for object Q, so now I have an object Q. So this is the object. Again, object Q is a object come with weight. So I have WQ and then I have a tension going upwards because it's being hung by a string. And this tension is just T because it's being hung by the same string, okay, as a P just now, object P. But for this one, for object Q, now your A is going up. Okay, therefore, we are going to take upward as a positive direction, downward as a negative direction. Let's look at the equations. So for object P, okay, object P. So object P, my object is moving with constant acceleration. So summations F equals to MPA. So in this case, I'm going to use WP minus T because I say downward is a positive direction. So equals to MPA. So but when it comes to object Q, okay, object Q, what happened now is that summations F is still equals to MQA. But now my acceleration is going up. Therefore, for object Q is T minus WQ equals to MQA. Okay, equals to MQA. So, so far, any questions? So far, any questions? So I think you write it down. The other 3 questions that involve leaf, I will keep it for our next lesson. Okay, when we discuss about the questions. So make sure you try the following exercises. Okay, the calculations questions by applying the things that we just learned. Okay, especially on how to sketch a diagram, how to solve the questions with a diagram. So you can start from a questions 3. Try to solve it. Okay, you try to solve it in terms of the x and y component. So this is the last questions that I'm going to discuss today. If no questions, then you may leave the class.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Okay.
Thank you, madam.
Thank you, madam.
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 Thank you, madam.
Okay.
Thank you, madam.
Okay.